delighted to welcome back Dr. Janice Stanger. Janice Stanger, PhD, is a nutrition expert, educator, speaker, and author of The Perfect Formula Diet, How to Lose Weight and Get Healthy Now with 6 Kinds of Whole Foods. Her mission is to provide you with solid, yet little-known information on whole foods, plant-based diets, so that you can choose your diet based on facts, not myths. Dr. Stanger has a PhD in Human Development and Aging from the University of California, San Francisco. She is certified in plant-based nutrition through the T. Colin Campbell Foundation and has an MBA also from the University of California, Berkeley. She is in her 18th year of critically analyzing scientific studies on nutrition and health. Dr. Stanger's presentation tonight is entitled, The Dangerous Truth About Protein. Please join me in welcoming Dr. Janice Stanger.
Okay, you've probably learned a pretty commonplace understanding about protein, that it's a superstar nutrient, that it magically builds muscle just by eating it and helps you get thin, and that it's something that's very rare and hard to get and you have to specially source it from certain foods. Well, what we're going to learn tonight is going to totally shred that misunderstanding. And what you learn will enable you to make much better choices in terms of the foods you eat, because in fact protein is actually a very abundant nutrient. It's one of the most abundant nutrients there is. It's very easy to consume to excess on a standard American diet, and in fact if you eat excess it can actually be very dangerous for you. So this will give you information to be able to make much better health choices. So there's just tons of misinformation circulating out there from just so many different sources, and one of them is actually our own government, the US Department of Agriculture. So let's start out looking at that one. So protein is an icon, and there's something very peculiar about this plate. This plate is called the Choose My Plate. It's the USDA's latest version of what we're all supposed to be eating. And there's a lot of fallacies on this plate, for example, the dairy fallacy that we're not talking about tonight. But the oddest thing about this plate, which really struck me very strongly the first time I saw it, is that protein is broken out as the only nutrient on this plate. So if you look at what the USDA is telling us to eat, everything else on here is a food, right? You could go to the supermarket, you could find it, you could point to it, you could go, that's a vegetable, that's a grain, that's dairy. You can't do that with protein. So the mindset they're trying to establish here is that protein is so rare that you actually have to get special foods to get it, and it kind of tells you implicitly that there's no protein in your vegetables, fruits, grains, or even in your dairy, because it's something that's so uncommon. So what does that lead to? It leads to a lot of things. In terms of business, you can see here, this is an aisle that's in just about any supermarket these days. This supermarket kind of comically calls it the nutrition aisle, because it's actually more like the anti-nutrition aisle. But what you see here are all kinds of protein products. A lot of them are powders. I mean, I'm sure you've all seen this aisles that go on almost forever with protein powders. A lot of them are from whey, which is actually a byproduct of making cheese. A lot of them are also sourced from different kind of plants. And they're also put into not just powders, but brownies and food bars and everything else you can think of. So again, this is a highly profitable, and people really are kind of making a lot of money off this misinformation about protein. But luckily there's a new science now, and it's called proteomics. And proteomics is something that will give us a lot more good information. So let's look at some of the basic facts. This science came to be in about very recently, but actually the discovery of protein goes back to 1838, 175 years ago. 2 European scientists discovered protein. And they gave it this name because they thought it was very important, because it comes from a Greek word meaning of prime importance. And there are a lot of misinformation started swirling at that time, and unfortunately it's still out there. So let's really start seeing some of the basic facts. Okay, so I want to ask you this. So how many kinds of protein do you think are in your body, you being the average person, okay? So we'll just do this by a show of hands because there's kind of too many people to count. So how many people think they have 1 to 99 kinds of protein in their body? Okay. How many people think they have 100 to 999? That one's a little less popular. How many think they have 1,000 up to close to 10,000? Okay. And how many think they have over 10,000? Okay, pretty good. So I'd say about half the people think they have over 10,000 and about half think they have under 10,000. In fact, according to the American Medical Association, we each have about 2 million kinds of protein in our body. And we'll see soon why that can be when we see what protein's made of, why you could actually have so many, and it doesn't even begin to put a small dent in the kinds of protein that could theoretically be made. So of every 100 calories in human breast milk, how many calories come from protein? This would be the milk that a nursing mother produces. So how many people think it's 1 to 4 calories? Okay, not too many. How many think it's 5 to 8? Okay, how many think the mom has 9 to 15 calories worth of protein? And how many think 16 or more? Okay, that's a vast majority of people. The correct answer is actually B. So in a nursing infant, one of the main functions of protein in the body is to fuel growth. So the time of life when we're growing the fastest, which is in infancy, actually only 5 to 8% of the calories that the infant is consuming come from protein. So that should tell you a little bit about our protein nutritional needs. But there is something very special about protein. So the people who think protein's very special, they're actually onto a truth here, which is that protein equals life. So the part of you that's alive, the part of you that breathes and thinks and reproduces and eats and does all that good stuff, actually is the protein part of you, because the other parts of you, like water and minerals, actually aren't alive. And this is true, this is the important thing. It's true not just of animals, but it's true of plants. So we all know plants are alive, and the part of plants that's living are also their proteins. And proteins, different proteins, are what makes each species unique from each other species, and also makes every single individual within that species unique from every other individual. So let's see why that is. And the reason it is, and the reason you can have so many millions of kinds of proteins, is because they're linked chains. So I just happened to bring a protein chain with me to kind of illustrate this fact. So here's my little protein chain, and in actuality the protein chain would be a lot longer because there's hundreds to thousands of these little links in each protein chain. So the chain itself is the protein. So what are the little links? This is the most important thing we're getting to. The little links are called amino acids. Okay, so these amino acids, when they're linked together, kind of like they're linked in this chain and then they get folded a certain way, are what make up a protein. So you really don't need protein at all. What you need are amino acids, because remember, your amino acids are unique. And so your proteins are unique, and your amino acids are what make up your protein. So since your protein is unique, you can't get that protein by eating any kind of food, plant or animal, because the animal you eat or the plant you eat is going to have very different protein from yours, but it's going to be made of these same amino acids. Okay, is that making sense? Okay, cool. So let's see why your proteins are put together the way they are. They're put together the way they are for a number of different reasons, but the most important is your genes. There's also dietary and environmental influences on which genes get expressed, which means which proteins are put together. So, as I talked about, there's hundreds of thousands of aminos in each of these chains. And where do you get these amino acids from? Well, you get them from your food. Okay, so we do need to eat the amino acids. We don't need to eat the proteins. So we're starting to get the core of what we need to know to make better decisions, to really understand what protein is, and to make better decisions about it. So where do these amino acids get made? So now we're getting to the really fundamental question. So you notice I have two colors on my little protein chain. Now there's actually 20 kinds of amino acids that make up all living things, whether they're plants or animals. But for our purposes, we can divide them into two kinds. We're not biochemists, so we don't have to sit here and memorize the 20 kinds of amino acids. We just need to know that some are non-essential. And what does non-essential mean? It means that you can make it yourself. Since you can make it yourself, you don't need to get it from food, you don't need to worry about it. It's like anything else your body can make, you just don't worry about it, it does it without you even having a conscious thought about it. The other amino acids are called essential amino acids, and that means your body can't make them, and that means you have to get them from food. So we only really care about getting the essential amino acids. So imagine in my little protein chain that the amino acids, the essential ones are green and the non-essential are red. And you notice there's a mix of them that your body needs. So where did the essential amino acids come from? That's probably the most important question in protein nutrition. And it turns out, again, they are made by plants. Now, why is that? It's because the essential amino acids take a lot of metabolic energy. They're hard to put together. They take a huge amount of energy to put together. Plants are solar powered. They're sitting out in the sun. They're getting all this wonderful energy direct from the sun, and they're converting it. They're able to use about 95% of the energy they get. And so they have enough energy to make these essential amino acids. Animals do not have that much metabolic energy, right? They're not solar powered. So all these essential amino acids come from plants, every single one of them. So what does that mean? It means animal protein is nothing but recycled plant protein. There's nothing in animal protein that is not in plant protein, because the animals got their essential amino acids by eating the plants. Remember, they can't make them. So another way to think of that is to say plants are the base of the food chain on planet Earth. That means that plants are nutrient producers, or the base of the food chain, they're nutrient producers. Animals are not the base of the food chain. That means animals are nutrient consumers. Very different role that nature's thought for them. So let's see another way to look at this. So take a good look at this cow. I want everybody to look at the cow, because this is another way of understanding it and remembering it. And if there's one thing you remember from tonight, I'd like it to be this picture of this cow. And remember that this cow is eating essential amino acids. This cow is not making any essential amino acids. So if you eat animal products, whether you choose to eat the cow's milk, you can tell this is a dairy cow, or whether you choose to eat her muscles or her organs or whatever part of her you eat, whatever proteins you're getting from that, in fact, originally came from the plants that the cow ate. At least all the essential amino acids came from the plants. Some of the non-essential ones the cow might have made herself, but you don't really need those because you can make them yourself. So we're getting close to what you need to know about protein to be able to go on and look at how it can harm you. Your body suffers quite a bit when you have the wrong kinds of protein and too much protein. And I'm going to look at just 3 ways this can happen. There's actually more than 3, but we'll try to focus on the 3 main ones tonight. And that should be enough to get you started. So the first danger of protein is that when you have too much of the wrong kinds, it can damage your liver and kidneys, which are clearly essential organs that you need to survive. Okay, you can't live without those organs. You actually have 2 kidneys and you don't need both of them, but you do need enough kidney function to be able to clean your blood and get rid of waste. And both these organs can be damaged. And I show a picture here. This is actually a kidney, because kidney disease is growing so rapidly. And one reason it's grown so rapidly is because of the food we eat. So this slide was actually taken very near here very recently in a shopping center that's about 10, 11 miles from here. And this is a directory of the shopping center. And it shows you all the health services in that shopping center. Obviously, they also have categories for restaurants and clothes and knickknacks and things like that. This just shows you the health services. And what are you seeing? You're seeing, you have the things you would expect to see. You would expect to see in any well-equipped shopping center some kind of fitness services and massage and yoga and exercise, weight loss, nails, and all that kind of stuff. But now you have a dialysis clinic. You have a dialysis clinic in this shopping center. You're going to be seeing a lot more of this because this is a real growth industry. And there are financial analysts who are telling you to go out and buy stock in dialysis center companies because kidney failure and end-stage renal disease is such a rapidly growing diagnosis. And, let's see how this relates to protein. So too much protein is a waste disposal process. So here's the thing about amino acids. Too much protein equals too many amino acids, because we already talked about what protein is. So your body has to get rid of this protein. Everything you eat, either you cannot absorb, but if you absorb it, then your body has to either use it or get rid of it. And people don't think of this when they're taking large amounts of supplements or whatever, but when you take too much, it's nothing but a toxic waste disposal problem for your body, and that's certainly true of protein as much as anything else. Because you have very limited room to store amino acids in your body. The amount of room you have to store amino acids is actually largely dependent on your height. It has virtually nothing to do with your diet. Taller people have a little more room, and that makes sense because they have a little more body mass to support for the most part. But it really, you can't increase the amount of protein or amino acids your body stores by eating them. And the other thing about protein is your body can't just burn it away. And it can't store it in the form of protein, and it can't burn it for fuel in the form of protein. So how is it going to get rid of it? It's like this overflowing trash can. It's like you have your overflowing trash cans, there's been a strike, nobody came to collect your trash, and now you had a big party and you just don't even know where to put all this trash. So that's kind of like the situation your body's in when you're getting too much protein. And it makes your liver and kidneys work overtime to get rid of it. What happens to it? Well, let's see, and then you'll understand why this is so harmful. Now, the first thing we have to look at is what you can use and what you can save for fuel, and that will really explain what happens to your protein. So the first picture you see here is glucose. And this is in a pure form. Usually when you eat food, you're not eating glucose in a pure form. Glucose is one kind of sugar, and there's multiple kinds of sugar. Again, we don't have to worry about that because we're not doing biochemistry tonight. But glucose is a form of sugar that your body prefers to burn as fuel. And in fact, it's the only fuel that your red blood cells can burn. So your red blood cells, which are necessary to carry oxygen, cannot live without glucose. Your brain also has an extremely strong preference for glucose. If it's really deprived of glucose, there's some other kinds of fuel it can burn to a limited extent, but it won't be working very efficiently or effectively, and it always does need some glucose. So your body without enough glucose is like a city with a power outage, like nothing happens, it's the end. And then the other nutrient your body knows what to do with, and here I'm talking about macronutrients or sources of calories, because remember, protein's a source of calories. So we've got the sugar, and then the other thing we have is the fat. Now, I'm not showing you this because I recommend you eat it. I'm showing it to you so you understand that your body can store fat, which probably we all know, and your body can store actually hundreds and hundreds of pounds of fat. Probably a lot more fat than any of us wanted to store, right? But, you know, so all these products you see in this picture are pure fat, and your body knows what to do with it. So again, your body knows what to do with the glucose, your body knows what to do with the fat, and it can handle it. But what about the protein? And by the way, I just told you protein's a macronutrient, which means it's a source of calories, but I also told you your body can't burn protein. So aren't I contradicting myself? Well, let's see. Now here we're getting into a little bit of chemistry light. Don't be afraid of this if you didn't much like chemistry. This is going to be very light chemistry, and I'm very confident you'll all understand it. So when we look at the amino acids, you'll understand all this, and you'll be able to see why the protein's so harmful and why you're really wasting your money when you have too much of it, if you're spending a lot of money for it. So the first thing we're looking at here, the thing in the upper left corner, is actually an amino acid. It's a representation of an amino acid. And you can see the amino acids made from 4 substances. There's the oxygen, the carbon, the hydrogen, and the nitrogen. Okay, that's what's making the amino acid. Now, the thing that's special about the amino acid that differentiates it from the other macronutrients is the nitrogen. So your body doesn't want the nitrogen. It can't really do much with the nitrogen, so it just kind of chops it off, okay? So just think of it as kind of cuts the nitrogen off, and we'll get to what it does to the nitrogen in a minute. But the other three that are left, which is the oxygen, the carbon, and the hydrogen, your body knows exactly what to do with. Because think carbon, oxygen, hydrogen, what does that sound like? It sounds like carbohydrates, doesn't it? Very well named macronutrient. So and glucose is one kind of carbohydrate. It's a simple carbohydrate. As we all know, there's many simple carbohydrates and a lot more even complex carbohydrates. So your body breaks down to the simple carbohydrates to burn for fuel, which includes the glucose, which is its preferred fuel. So it takes this carbon, oxygen, and hydrogen if you're low on glucose, because remember, if you're low on glucose, your survival is in danger, and your body is way too smart to let you die because you don't have enough glucose. It knows exactly what to do. It's going to make more. And that process is called gluconeogenesis. And that's really not very hard to remember because it's gluco for glucose, and then neo means new and genesis means make it. So it just means you're kind of making new glucose. That's all it means, but that's kind of the scientific technical term is gluconeogenesis. Now, what if you don't need glucose? What if you've been eating adequate carbohydrates and your body also can store some very, very limited amounts of glucose that'll last it about 20 minutes if you're exercising? What if you already have all that you need and your body can't store any more glucose? Well, then it takes these same elements and it just puts them together in a different way and it makes it into fat. Well, it knows what to do with fat, just stores it in case there's a famine next year and you'll make sure you'll have some calories to burn. So that's what happens to that. Your body knows right what to do with it. It's not really dangerous to you because those aren't really dangerous elements to have in your body. But let's look at the nitrogen. Let's look what happens to the nitrogen. And this is getting to the core of why you don't want to eat too much protein. It's because of the nitrogen. So the body has to get rid of the nitrogen. It can't really do anything with it like it can with the other three elements. So the nitrogen is going to react, and the first part of this takes place in the liver, and the second part takes place in your kidneys, which is why this process is very hard on those two organs. So the nitrogen, first thing that happens to it is it becomes ammonia. Now, do we really want to drink ammonia, have ammonia inside our bodies? Probably not. Ammonia is actually very toxic. It's very poisonous. I think everybody knows that. And so you have this ammonia flooding your liver. Well, it would immediately kill your liver, and you just can't have that in your body. It has to be deactivated immediately, which your body does in kind of a split second by going through a very complex cycle. It's a complex cycle, but it happens very quickly, and it turns it into a far less dangerous substance. It's called urea. Now again, remember this all happens in your liver, that the ammonia turns into the urea. There's actually a very small percent of babies born, it's like 1 in every 30,000 babies born, that lacks the enzymes to make this urea cycle work, which means the ammonia would basically kill the baby in a very short space of time. If this is discovered early, the baby can be saved by putting on an ultra-low calorie diet, an ultra-low protein diet rather, and then the baby's fine as long as it eats this ultra-low protein diet. It doesn't fast. It actually, the child has to be very careful, and then the adult, but it can survive. So that's how important this cycle is, okay? Now, what happens to the urea? You don't want this building up in your blood either, so it circulates through your blood, and when it gets to your kidneys filter it out. And guess what it does with the urea? It goes into your urine. That's why urine is called urine. It's from urea, okay? So then it gets excreted. Well, when there's too much of it and your kidney has to be working overtime to filter all this excess urea, which it does if you're eating too much protein, then that is very hard on your kidneys. And in fact, people that have kidney disease have to eat a very low protein diet, as do people who have serious liver disease, because processing the protein this way is very hard on those organs. But why wait till you have that problem? Why wait until you have end-stage kidney disease before you cut down to an appropriate amount of protein? Why don't you do it beforehand so you don't get end-stage kidney disease, so you don't end up in that dialysis clinic in your nearest shopping center? Okay, so that is pretty much the first danger of eating protein that we've just gone over, is the harm to your liver and kidneys, but there's more. So let's look at protein danger number 2, which is the excess protein makes your cancer grow faster. If you have cancer cells in your body, excess protein is not a good thing. It's going to make them thrive. So let's look at why that is. Well, there's multiple reasons. There's not just one mechanism, but this is one of the most important mechanisms of why protein makes cancer thrive, and that is production of a hormone called insulin-like growth factor 1, or IGF-1 for short. Now, IGF-1 is an essential hormone. It regulates a lot of your body metabolism, your growth at the stage of your life cycle when you're still growing in childhood and when you're a teenager. It regulates cell division, cell death, and all those things. And certain proteins in diet will raise IGF-1 levels. And the protein that's most strongly implicated in that is actually dairy protein. So dairy foods are the ones that will make the IGF soar to the highest level. And that makes sense because there's actually IGF-1 in dairy products, because remember, it's produced by the mom cow for her calf, who's a little tiny thing that she wants to grow up drinking her milk. So she's going to nurse a calf to grow, but unfortunately, you're not a little calf. So when you consume it, you're getting all this growth factor, but you don't need it, and it's extremely dangerous. So how does it stimulate cancer cell growth? Well, there's a few ways. One is that the growth hormone itself, because it's stimulating cell division, is making the cancer cells divide faster. And by the way, cancer cells appear to be more susceptible to the effect of IGF-1 than normal cells are. So they are going to start dividing faster than they otherwise would have. There's another mechanism, which is that there's something called normal cell death. And this is actually a normal programmed part of you, that if you have a diseased or damaged cell, or a cell that's become non-functional, it's supposed to self-destruct. That's how your body's programmed. It's actually very important it does that. Well, cancer cells usually won't self-destruct, but if there's not too much IGF-1, they will. So this normal self-destructive process is basically deactivated by the excess IGF-1. And then another thing, because the IGF-1 is fueling growth, is it's fueling the blood vessels that nourish the tumor if you have a tumor. You know, tumors grow when they're nourished by excess blood vessels, and there's a lot of cancer drugs now that are coming out that work by keeping these blood vessels from growing to, you know, the tumors. So you can actually have a lot of that same effect just by not having the IGF-1 from all these excess animal foods. Now, there's one more thing I want to mention about protein and the level of IGF-1. We've talked about dairy protein is the worst. Other animal proteins are very bad too. It appears that highly concentrated plant proteins, and here I'm not talking about whole foods, but things like soy protein powders, and this has not been studied as extensively as the animal foods, but they also cause levels of IGF-1 to go up, because remember, the function of protein is to facilitate growth. That's one of its functions. So the plant that's been studied most for is soy, the isolated soy protein powders. This has nothing to do with whole soy. I don't want anybody in this room to misunderstand and say, I'm not going to eat edamame, I'm not going to eat tofu, I'm not going to eat tempeh or soy yogurt. It has nothing to do with those. Those are not highly processed foods. It has to do with the kind of protein that's been extracted from the soybean and basically gets sold as a white powder that you can buy and just eat to excess, or that gets used to make, sometimes gets used to make imitation meats or something like that. So you want to avoid these concentrated protein powders, even if they're from plants. So remember, we saw the nutrition aisle. You know, you want to be healthy, you want to kind of just stay off that aisle. Soy milk is fine. Someone asked about soy milk. Soy milk is fine. That's also not highly processed. The point is, soy milk, things like that, are not highly processed. What I'm talking about are things, it's actually a powder that you buy in a jug that's made in a factory. So let's get on to the third mechanism by which too much protein of the wrong kind can harm you, and that is the protein can cause inflammation throughout your body. So let's see why that's important. Well, inflammation is a natural process. It's very protective. It's a function mostly of your immune system, but also of your nervous system. You have to have inflammation to protect you from things like microbes and injury to heal after, say, you burn yourself or scrape yourself or cut yourself or anything like that. You have to have inflammation to help you heal. And that's all your immune system protecting you. But some proteins cause excess inflammation. Now remember, your immune system's protecting you. What's it protecting you from? It's protecting you from things that could hurt you. Now remember, we talked about our chain, our protein chain, and the ideal is that when you digest a protein chain, you break it into all these amino acids. The amino acids are absorbed, and they're no longer proteins, so they're not going to incite your immune system. They will incite your liver and kidneys, as we talked about. They won't incite your immune system. But here's the thing. Oftentimes, a large part of this chain does not get broken down in the digestion process, because that process is about 99% right on, but about 1% of the time it's incomplete. So when you think of all the proteins you eat, about 1% of the time, a large part of the chain is going to be absorbed into your body intact. And that becomes a foreign protein in your body that your immune system can say, I don't like this. Now this happens many times a day, so your immune system can't go crazy on every kind of protein, so what kind of protein is it going to be looking out for? Well, it's not usually looking out for plant proteins, because plants aren't going to hurt you. Remember, plants are kind of self-sufficient. They're out there. We talked about they're growing in the sun. They're the base of the food chain. They make or absorb their own nutrients. They really don't need you. So plants not going to come, you know, your rose bush isn't going to come and invade your body and take you over and kill you, right? What it's looking for is foreign animal proteins, because animals are nutrient consumers, and some of them might very well want to consume you. And that would be things like parasites or microbes that are in the animal kingdom that want to consume you. So that's what your immune system is on the lookout for, and what it's going to react to with inflammation. Now you might be saying, well, inflammation is actually protective. You just told me inflammation is protective, so why should I care about it? And the answer is that yes, it is protective when it's in the acute stage, which is right after you've faced a threat, or let's say right after you cut yourself, or right after you've been attacked by some cold viruses or parasites or something like that. But if it goes on and on and on, that is, it becomes chronic, that's a different story. Then it becomes destructive, because it never has a chance to heal. So remember, the inflammation starts out protecting you, deactivating the invader very aggressively, and then it helps you to heal. Well, when you have chronic inflammation, you never get into that healing phase, because it's as if you had a scrape. If you had a scrape, after a few days it would start to heal. But if you got a scrape and every single day you took some steel wool and you kept scraping and scraping and scraping it and scraping it and scraping it, it would never heal right, because you'd be irritating it every day. And that's the same thing when you're eating these foreign proteins that your body perceives as threats several times a day. It causes the chronic inflammation. Now again, it's not the only thing that causes chronic inflammation. It's something that needs to be really studied quite a bit more. It's something that not nearly enough energy has been devoted to studying, because in fact, chronic inflammation underlies most chronic disease. That includes hypertension, cardiovascular disease, autoimmune diseases, type 2 diabetes, you know, all the common killers, and the things that make you uncomfortable, things like sinusitis or headaches that aren't necessarily going to kill you, but they make your life miserable, are all examples of chronic inflammation. So you really don't want to be fueling this chronic inflammation. You want to be giving your body a break so it can heal and the inflammation can go away. So that's another reason you don't want to be consuming these proteins. Again, this is something that there should be a lot more research on. There is quite a few studies out that look at, you know, the effect of animal foods and processed foods and whole plant foods on inflammation in the body, using certain markers of inflammation. And what they find is that animal foods and extremely highly processed plant foods do cause more inflammation, whereas whole plant foods cause you to have a balanced inflammatory state. In other words, you're in exactly the state you should be. You don't want to go from one extreme to the other. You don't want to not jump off one cliff and run the other way screaming and fall off the cliff that's a mile down the road. So you don't want to go from being pro-inflammatory to anti-inflammatory. You want to be balanced, and that's what whole foods help you do. So let's look at what some of these myths are and what you can do to make better choices. So the first myth is that plants don't have enough protein. Well, we already kind of debunked this one, but I wanted to circle back to it because this one is so important. I think it's very critical to be explicit with it for you to see that this really is not the case. So what did we learn about plant protein? We learned that plants are the base of the food chain and they make all the essential amino acids. Now, these amino acids do get more concentrated in animal muscle, but they get more concentrated than you really need, and that can be a source of ill health, as we just saw. The plants have plenty of protein. Why? Because the plants need protein. You know that if you're a gardener. If you're a gardener, you know your plants need nitrogen. Remember, we looked at nitrogen as a special element of protein. Why do you have to give your plants nitrogen fertilizer? It's because the plants are making protein. Okay, in fact, about 30% of the dry weight of plant cells is actually protein, and it's a living thing of the plants. So this whole idea that plants don't have enough protein is wrong on any number of counts. But there's even another reason why this doesn't make sense, which is that your body recycles amino acids. So your body is actually very efficient, and your body isn't going to waste anything that it can use or reuse. So it's kind of like this fountain. This picture is actually a very nice fountain in Balboa Park in San Diego. It's one of my favorite fountains. And you can see what the fountain is doing. The fountain is spraying water, and then what happens to the water? The fountain reuses the water, okay? So if this fountain needs 100 gallons of water, does the city of San Diego need to put 100 gallons of water in this fountain every day? Of course not. Because the fountain is just recycling and recycling and recycling the water. It needs to put a tiny bit in eventually because some of the water will evaporate and some might splash out or something like that. But basically it just keeps recycling and recirculating, and it's exactly what happens to your amino acids. Remember, they're building blocks. They're these little building blocks. So you can reuse them again and again and again and again and again. So that's why you don't need to take in that much. You know, if you weigh 150 pounds, you don't need to eat 150 pounds of protein every day. And actually a lot of that weight is water and minerals, but whatever weight is protein, you don't need to eat that every day because your body is recycling the aminos. And it actually excels best at conserving the amino acids that are least common in foods. So remember we talked about we have amino acid storage pools, but they're very small. Your body will preferentially fill them up with the amino acids that are hardest to get from foods. And that's one reason you don't have to worry about mixing and matching protein. There's that myth that, you know, if you eat plant foods, you should eat beans and rice or that kind of thing because they have complementary, you know, amino acids. It's actually totally untrue. Every plant has all 20 amino acids, both the essential and the non-essential. It needs it to live. And in fact, even if it were true, you wouldn't have to worry about it because your body's going to preferentially conserve the amino acids it has the hardest time getting. So let's look at myth number 2, which is the myth that was on the USDA plate. Remember that little graphic I showed you where there was a whole quarter of the plate that was devoted to protein. You're supposed to put protein on. Why not you're supposed to put on it a chain like this and eat it? I don't know. They're not very explicit, not very much help. But the point is that plate is extremely misleading because everything on that plate had protein. It was made from protein. We've just been talking about that. So the vegetables are full of protein. The fruit actually is the food that's lowest in protein, but still it was a living thing, so it has protein. And the whole grains are very high in protein. So you don't need a special source of protein because every single solitary thing on the plate has protein in it. And yet you're taught to look at protein as kind of like the center of the meal. It's the most valuable thing. It's the thing you center your whole meal about, is this protein, right? It's just a total myth. And the source of protein myth causes just absolutely no end of mischief. You don't need a special source of protein in your food any more than you need a special source of oxygen in your air, right? You don't need to go to one corner of the room to get your oxygen, because the oxygen is evenly diffused throughout the whole room. And it's the same thing with the protein. It's diffused throughout everything you eat. Therefore, you do not need a special source of it. Okay, so there's another very common myth that keeps people just glomming down what they see as protein, animal food these days. So let's see what that myth is. Okay, so it's a myth that your ancestors ate lots of animal protein, and therefore you should too. Because after all, you wouldn't want to do anything different from what your ancestors did 2.5 million years ago, would you? So let's look at this one in a little bit more detail. This is called the paleo diet, the caveman diet. It has some other names, so it doesn't really matter what it's called. Basically, it's a diet that tells you to eat lots and lots and lots of meat, not to eat dairy, so you're going to eat meat, basically fruits and vegetables. You're told not to eat grain, not to eat beans, and just to eat basically the meats, fruits and vegetables, which is supposedly what your ancestors ate 2.5 million years ago. Well, that makes a very nice, appealing story, because it sets you up to think you can kind of be in communication with your ancestors 2.5 million years ago just by eating the foods they ate. But there's a little problem with this story, which is that it's a total fairy tale, and it gets you eating a disease-inducing diet that's actually very harmful. And I don't have time tonight to go into all the aspects of this myth. I would be here for over an hour just going over this, but let me just hit a few of the highlights so you realize how absolutely ridiculous this is. First off, 2.5 million years ago, your ancestors did not look anything like what we look like now. It's a totally different species of hominid than we are now. So they actually had very thick teeth and very thick jaws. And you can actually see this if you want to look it up on Smithsonian website. You just can search for it. They have a very nice little family tree of how humans evolved, and shows you very nice pictures at each step of the way. So our ancestors had such thick teeth and such thick jaws at that point that it's thought that they actually ate tree bark, far from eating meat. So here they are living on the savannas of Africa, where we can see that there's all these large animals, and it's hot, and there's not much shade. Now, even the paleo diet proponents say that, in fact, humans back then had very primitive tools, and they would have a very hard time with those extremely primitive tools hunting these animals and killing them. So then where were they supposed to get all this meat? Well, the answer that is given by these kind of diets is they got it by eating the kill of large carnivores. It's not too likely that a band of cavemen were going to come along and steal this meat from the lion. So, I mean, there's just even more grounds this could be faulted on, but when you start thinking about it, you realize that this is a very appealing diet, and the people putting it out there are making millions of dollars off it, if not more, but it does nothing for your health. So now we've looked at 3 of the main myths that keep you eating protein unnecessarily. So let's look into, well, you might be thinking to yourself, well, what should I be eating instead? Okay, well, let's look at that. If you're not going to be eating all this animal food, what are you going to eat to get the optimal amount of protein and the right kind of protein, so you don't, get this highly dreaded protein deficiency diseases? So the first thing to do if you're on a plant-based diet, a whole food plant-based diet, which is what I'm going to talk about, is don't stress about protein, and don't dissect your food. Dr. T. Colin Campbell, probably most of you have heard of him. He's the author of the China study, has said your body does the math. That's a very important thing to remember. Your body does the math when you eat a whole food plant-based diet. You don't have to worry about it. You don't have to start dissecting it. And so that way that's profoundly liberating, because you don't have to go around and try to be counting grams of protein or carbs or anything else. It's just going to be automatic. And the reason it shows a little team here is that these whole food nutrients are a superstar team, and they all work together very synergistically. And this is true for everyone. Again, there's another whole series of myths out there that it's true for some people but not others because of their blood type. Well, you know, we just talked about the fact that there's over 2 million kinds of protein in your body. Why would one protein out of those over 2 million determine what you should eat? Does that make any sense to you? Hopefully not at this point. So there's no relation to blood type whatsoever. It's not a function of genetics. Within each species, every individual in that species eats pretty much the same thing. So there's no reason to think people would be any different. So for example, if you think about rabbits, just to take a totally random example, some rabbits, you wouldn't say some rabbits eat grass and other rabbits eat fish, right? The rabbits, they're going to eat plants. And it's the same thing with humans. We are all clearly genetically different, just like all the rabbits are genetically different, but it doesn't mean we're eating different foods because we're eating the food that our species is designed for. So the whole plant foods are going to keep you on target. They're going to get you the right amount of protein and the right kind of protein, which, as we just talked about, you want to be at the center of the bullseye, and the animal food diet is keeping you way above the center of the bullseye. You're not even on the target anymore. So how does that happen? What whole food plant-based diet should you eat? Well, there's no one answer. I mean, you guys have a lot of speakers here, and you're going to hear different information, and it's all good information, and there's a lot of kinds of whole food plant-based diets you can eat and be healthy. I'm going to suggest one that I call the perfect formula diet that works very well. I don't want you to think it's the only one, but this one is very simple to follow and is going to get you the right amount of calories, nutrients, and protein. And there's 4 pillars of this diet. So a quarter is vegetables, a quarter is fruit, a quarter is potatoes and legumes, and a quarter is whole grains. Legumes, by the way, are like beans and peas. And you can think of a quarter as being like the plate because it's like volume. So if you look at a plate, but not the USDA plate, a different plate, and you cut it into quarters, you're going to eat a quarter of each of these kind of foods. And you don't have to be really rigorous about it. You don't have to eat them in any special order. You don't have to worry if you eat 3 baked potatoes in a row. The point is, you just want to eat generous amounts of all these kind of foods. You want to eat when you're hungry, moderately hungry. You don't want to wait till you're famished. You want to eat slowly and enjoy your food and stop eating when you're full. And that's pretty much all there is to it. Now, there are more whole foods for health. You can add, first off, herbs and spices, which I always like to think of as another kind of whole food because they make your food more interesting, flavorful. They have a lot of very beneficial phytonutrients in them. They keep your food interesting. They keep you from adding so much salt to your food because you can enjoy the spices instead of just pouring on salt. So you want to do that. And then in terms of nuts, people ask about nuts a lot. You want to just eat small amounts. So, you know, you might eat a handful or 2 a day. You don't have to eat nuts, but if you enjoy nuts or nut butters and you want to make a peanut butter sandwich or some kind of nut sauce or something like that, it's fine to eat the nuts. To these 6 whole food categories, there's not much you have to worry about. We're not going to talk about omega-3s tonight, but to the extent that you're worrying about omega-3s and you know you need to balance your omega-3s and omega-6s, you want to eat ground flaxseed for that. And again, another easy way to do that is just don't eat oils. Remember, plant oils are a processed food. I showed you that picture of plant oils sitting in jars in the supermarket shelves. That's highly processed food. That is not a whole food. So when we're thinking of grains, whole grains are whole foods. Things like white bread and white rice are not whole food. Fats, things like nuts and avocados and olives are whole foods. The oils, the separated oils that come in a jar or in a tub are not whole foods. So you want to stay away from things that are highly processed, even if they're plants. And that's the essence of the whole food plant-based diet. Now there's 2 essential nutrients you need that don't really come from food, and they're not part of the plant food chain, so you want to have to worry about them separately. So one is vitamin B12. So the vitamins you need, the only vitamin that is not made by plants is B12, which are actually made by bacteria. So bacteria make your B12. So you don't want to eat contaminated food that's very highly laced with bacteria or drink contaminated water that's full of bacteria. And we all sterilize everything these days, which Remember, our ancestors on the savannas of Africa did not sterilize their food, so they were getting lots of B12. But we eat sterilized food, so where are you going to get your B12? Well, the simplest thing is just take a supplement. And it's really the only supplement I would recommend is the B12, because it's very inexpensive. You're not going to be harmed by taking it. You know, no, you're not really going to take too much. Just get a bottle and take it, and don't worry, is it in my nutritional yeast? Is it in my breakfast cereal? And then vitamin D is something you actually make here in Hawaii by having the sun on your skin. If you're unfortunate enough to live somewhere where there's not much sun, you might actually have to end up taking a D supplement, but we very much prefer not to do that, for you to get enough sun that you can make your own vitamin D, which is not to say an excess of sun, but enough to make your own vitamin D. And that's kind of a complicated subject in its own right, but to boil it down, for most people, that's about 15 to 20 minutes a day. It can vary based on a lot of factors, but if you can get that much sun on most days, you're going to be okay for most people. Again, you can be tested for it, but those are really the only two nutrients you have to worry about on a whole food plant-based diet in terms of breaking it out and consuming them separately. You don't have to worry about the protein, the vitamins, the minerals, or anything like that. You're going to get the right amount. So actually, it's very simple. I hope you're sitting there going, gee, this is a lot simpler than I thought it was going to be. This is easy to do, and I've learned some things. I've learned when I eat too much protein, it's turned into glucose and fat, and that's not what I want, and I'm spending $30 a jar on this protein powder, and it's doing nothing but destroying my liver and kidneys and causing inflammation and making any cancer cells grow. So I don't really need this. I'm just going to eat whole plant foods and get what I need. So if you look at this slide, this lady's going to show us how easy it is. It's really that easy. It's really the foods you put in your cart. Just buy a bunch of whole foods, enjoy them, cook them up, make them into soups and salads and rice and pasta dishes and sandwiches and burritos and healthy desserts and smoothies and all kinds of great things, and enjoy your food. Thanks. Okay, the question was, what about extra virgin olive oil and coconut oil and other kinds of oil that have been touted as like health miracles and we need to eat them? They're actually highly processed foods. You don't need them. They're actually inflammatory, and they're very, very highly concentrated sources of calories. So you really don't want to have those. So I would stay away from any processed food, but especially oil. You know, you've all heard sugar is bad, so the thing to remember is sugar is bad, but oil is worse, because it has over twice the calories per spoonful. Neither one of them has any nutrients that you need. The sugar doesn't have nutrients and the oil doesn't have nutrients, but the oil has over twice as many empty calories, so no reason to eat it. Okay, I believe the question, if I heard you right, was what are the signs of ammonia poisoning? You would be dead. So that's a sign. If you were poisoned with ammonia, you're dead. And that's what happens to those infants who are born unable to turn ammonia into urea unless they're put on an ultra-low protein diet. All right, I think the question was about gluten intolerance, correct? Okay. Gluten is a wheat protein. It's also in some other kinds of whole grain, but people think of it mostly in connection with wheat. And it's just a kind of protein in the wheat. There are people with a disease called celiac disease that cannot process this particular protein, and it can be a huge issue for them and cause extremely serious health problems. That's thought to be about 1 out of every 133 people. No, the question was, does gluten cause inflammation in everyone? No. Animal protein causes inflammation with far greater frequency than gluten, which is just a plant protein. The people that have been shown to be the longest lived people on the planet are actually people who were on a traditional diet in Okinawa, which is actually a tropical area where it's a beautiful tropical island where, you know, plants grow in abundance just like they grow in abundance on Hawaii. And this has been scientifically proven and documented that Okinawans, in fact, and again, I'm not talking about them today because now they're eating McDonald's and all kinds of stuff, but the ones that ate the traditional diet had the highest concentration of people who lived to be over 100 of any culture on the entire planet. So what did those people eat? These are the healthy, long-lived people. Well, there's been some research done about what they ate, and in fact, there's a lot of information in the archives about what they ate. These people got approximately 9% of their calories from protein, about 6% from fat, about 85% from carbohydrates, and a full 69% of their calories came from one food. Anybody want to guess what this food contributed 69% of calories? Sweet potatoes. Somebody said sweet potatoes. Very smart. They got 69% of their calories from sweet potatoes. So I don't think we want to hold up people who live in very marginal places as the ideal we want to strive to for our food. Okay, thanks everybody. I'll be hanging around a little bit.
Thank you, Dr. Stanger, for a very informative talk about an important nutrient that's well known, yet little understood by most of us. We'd like now to invite all of you to enjoy some delicious samples of vegan foods donated by the generosity of Down to Earth. Mahalo to all of you for coming, and have a safe return home. Good night, everyone.
This program is brought to you by the Vegetarian Society of Hawaii, a nonprofit organization dedicated to sharing with the community the many benefits of a vegetarian diet. Free monthly meetings include vegetarian experts found locally and on the mainland, quick and easy cooking demonstrations, and healthful and delicious food samples. Members enjoy an informative quarterly newsletter, social activities, and discounts at many vegetarian-friendly restaurants and health food stores. For an application, call 944-8344. That's 944-8344. Or visit our website at www.vsh.org. vsh.org.